In order to catch a ball, a baseball player moves his or her hand backward in the direction of the ball's motion. Doing this can reduce the force of impact on the player's hand because so when you look at this has to do with impulse. Impulse is J equals F delta T. Delta T is the time. F is the force of the impact. So you have a baseball player, and he's going to catch a ball. The ball has a force of 2 newtons on the player, and it will take 5 seconds for the ball to reach him. In 5 seconds, when he catches that ball, all 2 newtons will be applied to his hand. Now if he were to push his hand backward in the force of the direction of the ball and give it an additional 2 seconds, then the total amount of time for the player to react to the 2 newtons of force is 7 seconds. Two newtons over 5 seconds is greater than 2 newtons over 7 seconds, which is why when the baseball player brings his hand back, the force is less, the impulse is less. A freight car runs into an identical car at rest on the track. The cars couple with each other compared to the velocity of the first car before the collision, and the velocity, what will the velocity be after the collision? Say you have 2 cars that both have equal mass of 1,000 kilograms. The car is at rest, 0 meters per second. The car in motion is moving at 45 meters per second. When they collide, since the masses are the same, the speed will be 1/2 of what it initially was. Because if you think of it as a whole system and the 2 carts equal 1, one cart that's not moving is 1/2 of the other cart. Reason padded dashboards are used in cars is that in this you would use J equals force over delta T. An unpadded dashboard will give a smaller amount of time for the person's head to react to the impact force. Therefore, the impulse is greater. If you have a padded dashboard, the time in which the person's head has to react to the force being applied is a lot greater. You have a larger amount of time with the same amount of force. and therefore the impulse will be smaller. Suppose an astronaut in outer space wishes to toss a ball against a very massive and perfectly elastic concrete wall and catch it as it bounces back. If the ball is as massive as the astronaut, then so you take a person who is throwing a ball that is just as large as they are against a massive, perfectly elastic wall. When the ball is thrown against this elastic wall, massive elastic wall, the gravitational pull from the wall, since they are in space, is greater than the gravitational pull from the man. Therefore, when he throws the ball, it will remain at the wall because the gravitational pull is larger than the man. A tennis ball launcher is fired. Compared to the impulse on the ball, the impulse on the launcher is so impulse is J equals force delta T. Now this has nothing to do with mass. There is no mass involved. There's no velocity involved. This means that the impulse should be exactly the same. The force applied on the ball is the same that is applied on the air cannon, and the time in which it has to react to that force are both the same. Therefore, the force of the launcher equals the force on the ball. The time that it has to react for the launcher is equal to the time that the ball has to react to the force. If all people, animals, trains, and trucks all over the world begin to walk or run east, then so take the globe. You have a compass in the corner, north, south, east, and west. So the Earth rotates from east to west. The sun rises in the east, it lowers in the west. If you were to have everyone run east, opposite of the direction of the rotation of the planet, the globe would begin to slow down. Or they move west, if they're running east, then it will slow the rotation of the Earth. The momentum of a system is conserved only when so say that you have a car. This car is moving forward at 25 miles per hour. The only way that this car will change the momentum is when there's a force, external force acted upon it. Say you have a brick wall. The brick wall is not moving. Therefore, it is 0 miles per hour. The momentum is only conserved when there is no force, a net force acting on the system, external net force. Therefore, the momentum of this system was not conserved.